Hey guys, for the second part of the day, we're just going to go back to doing some square root addition and subtraction. It's going back to our radicals we were talking about yesterday, right? So I'm going to go to 21. Okay, and very similar to fractions, if the number underneath the house is the same, we can just add or subtract the outside. So in this case, we think about 7 plus 5, square root of 3, right? So 7 plus 5, we know that's 12. Square root of 3. Okay, that's pretty easy, right? Just think about fractions when we're talking about like parts of a whole, like 1/3 and 2/3 can be combined, right? Okay, if we're looking at, let's say, 22 over here, right? We see that the number underneath the house is 7 and the number underneath the house is 7, right? We do the same thing with subtraction, right? We're just going to say 6 minus 4 square root of 7, right? So that's 2 square root of 7, right? I know it says 22, but we're going to look at this one next, right? So now we have two numbers underneath that are not the same, right? There's a 50 here, and there's a square root of 32. So we're going to have to go back to our prime factorization like we were doing with our factor tree, right? So we have to find two numbers that split off and multiply into 50, okay? I'm going to use 5 and 10. I think that's pretty easy. So square root of 5 and 10, right? I know 5 is prime, so I'm going to circle that one. I have 10 that I know can be 2 times 5. Okay, and I'm going to do the same thing I did yesterday, okay? So, but this time I have to include that -3. So I have -3 times square root of 2 times square root of 5 times square root of 5. Again, just like yesterday, I'm applying that there are pairs. So that is a 5 times square root of 2 times -3. So I have -3 times 5 on the outside, so that's -15 square root of 2, right? So I'm going to write that up here. Okay, minus square root of 32. I know that there are two numbers that can equal 32. You could do 2 and 16 or something like that. I'm going to do 32 divided by 4 is 8, so I have 4 and 8. So 4 I know can be divided into square root of 2 times square root of 2, which are both prime. And 8 I could break down into 2 and 4. And so then I have 2 and 2. So I have, if I think about it right, I have square root of 2 times 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 square root of 2. So I have 2 pairs of 2, so I have 2 times 2 times square root of 2. So I have 2 times 2 is 4, square root of 2. Okay, and so then I just do what I just did with all the others. Remember, it's -15 minus 4 is -19. So that's my final answer. Okay, so that's a subtraction. Let's look at an addition because I'm going to skip down to 24 over here so we can do an addition just to refresh a little bit. Okay, so there are a couple things here. We could go ahead and do 48. I see that 48, if I look at my calculator, 48 divided by 4 is 12, right? So I have 4 and I have 12, right? 4 I can break down into 2 times 2 pretty easily. And then I have 12. I'm going to do 3 times 4, right? Square root of 3 is prime, and then 4 is 2 and 2. Okay. If I have this, remember, I have to have the 5 here, so I'm going to put the 5 here so I don't forget, because that's what I normally do. I have square root of 2 times square root of 2. Then I have square root of 2, square root of 2, and a square root of 3. Again, I have to look for pairs. I see that this is a 2, and there's a 2, so it's going to be 5 times 2 times 2, square root of 3. 5 times 2 is 20. So it's going to be 20 square root of 3. I'm going to put that up top right here so I don't forget. I'm going to put the plus 12, right? 12 doesn't work anymore. And so we could do square root of 3 and 4. So we have square root of 2 and 2 because 2 times 2 is 4. So I'm going to kind of separate this off. So I have square root of 2 times square root of 2 times square root of 3. So I'll have a 2 square root of 3 as the final product. They both have a square root of 3 here. So I just add 20 plus 2 is 22. And I put square root of 3. Okay. The ones on the back on 23 and 24, right, or 25, you can do those. I want you guys to do 23 and show it to me. I'm going to go down to simplifying monomials now. And so I'm actually going to ignore 26 because we've already done it. But just some review here, right? Mainly I'm going to focus on 27 and 29. But we see a power of a power rule, so we know we're going to have to multiply first. Remember, we put a 3 here, and we put negative. So we have negative 4 to the third power. We have u to the third power. And then that v, right, we multiply the 3 and the 2, and that's 6. So in my calculator, remember, I put in parentheses negative 4 cubed. And I have negative 64 u cubed v to the 6th power. And there's nothing else I can combine from there. So there's that. Okay. And then 29 kind of combines 28 and 27. So just a reminder here, right? Again, I'm going to do power of a power first. So I have 2 to the 4th power times b, and then 6 times 4 is 24. And then I do the same thing on the bottom, right? So I have 8 squared b to the 8th power. And so if I do 2 to the 4th power in my calculator, I have 16 b to the 24 on the top. And then 8 squared, I know in my calculator, is 64 b to the 8th. A couple of things here. When we have a fraction, we're just going to plug the fraction into the calculator just like we normally would, or do the division, right? So alpha y equals 16 over 64. And so you can actually see that this is 1 over 4. And so this is, then I have my b's over each other. When we're dividing, we subtract. So 24 minus 8 is 16. So we have b to the 16th power. Okay, so we can rewrite this as b over 16 over 4. Or you could keep that as 1/4 b to the 16th power. And those are our answers. Really, guys, this is a quick review from yesterday on the bottom. But just keeping it fresh, keeping it, on your brain. And that's it.